So where do all these meltwater streams go, and where do they come from? Streams go. Okay, I thought that was a mistake. First case may be just through moulins. Moulins, as I said, are pretty big holes that just gather the streams where the stream ends, and it cuts through the glacier. It's not a crevasse. A crevasse doesn't go that deep, like 30 meters max. A moulin can go through the glacier and eventually reaches the bed. So a moulin is a near vertical circular hole where water enters from the supraglacial to the englacial environment. And when it reaches the bed, it becomes subglacial. So that's just a video showing a moulin and what it looks like. You have the link in the slide. I'm going to speed up. So as you can see, those are like basically rivers on the surface of the ice, and they can really go fast. At some points, it reaches a hole and disappears. Let's see, are there a bit more images of that? Yeah, this video is really nice. You should look at it. Have a look at it. Very, very cool images. Also super scary. Like moulins, you don't want to fall in one. That's like a fall of a few hundred meters, in some places a few kilometers. So super scary stuff. And you can yeah, you can ice climb in those. The ice is not that great to ice climb. There are some ice climbers here. Glacier ice is not great. It's like popcorn. You're better off in a place like Fox or Dragonfly to start ice climbing and have nicer ice. So yeah, you can have moulins that are in the accumulation area, kind of hidden beneath the fern and the snow, but they can appear once they pass the equilibrium line and the snow and fern goes away, and you already have those features appearing clearly on the glacier. So as I said, the meltwater from the moulins goes to the bedrock as it travels through the glacier and glacial and reaches the bedrock at the interface where it becomes subglacial. So what happens with this? That's the last slide of this video. We're going to transition to another one after that. But the important message here, and we're starting to touch the importance of the hydrological system of glaciers, is that all that meltwater that arrives to the bedrock is going to lubricate the ice and increase the basal sliding at the start of the melt season, meaning that it will trigger a faster movement of ice at the beginning of the melt season. And we are going to see how this lubrication evolves throughout the melt season. At the end of the melt season, there is what we call a channelized subglacial drainage network that actually slows the glacier back down. So I'm going to try to explain that. I'm going to spend a bit of time on that. It's a very important concept. You're in winter. Let's say at the end of winter, the glacier is dry, meaning it's pretty cold, moving very slowly. There's no water because it's not melting yet. And all the holes, so the ice is a solid that behaves on longer time scales as a viscous liquid. And the ice has what we call creep closure, meaning that every time you drill a hole into the ice, it's gonna close by itself pretty quickly after a few days, actually. So anything that any hole or drainage or network or some kind of river that was carved into the glacier during the last melt season is going to be closed up by the end of winter, or most of those things. If you take, for example, Kestner Glacier, the hole is so big that it never really closes, but smaller rivers, smaller holes through the ice will close up during the winter. So you arrive at the beginning of summer and you imagine a block of ice. You start melting water at the beginning of the melt season, beginning of summer, and that water starts making a lot of small holes into the ice, a lot of small networks. That's what we have here at the top of the figure. And those holes are very efficient to lubricate the glacier. When we talk about that lubrication layer at the base of the glacier, that is not like meters thick of water. That is only a few millimeters, max few centimeters of water that is easing the sliding of the ice on the bedrock. So if you have a lot of very small rivers or streams beneath the glacier, you're gonna lubricate a big area of ice, and therefore, if you don't need, therefore, the bigger the lubricated area of ice there is, and the faster the ice will go. So now you're going through the melt season, you're melting a lot of ice, and what naturally happens is that all those streams kind of condensate into one bigger drainage system, and that's what we call a channelized drainage network, meaning that all the small capillaries, all the small networks gathered into mostly one stream that goes out the glacier. So what happens is that you reduce the area of the ice that was well lubricated. And what happens if you reduce the area of ice that is lubricated at the bed? Then your glacier slows down. So you already have that super interesting concept where the ice goes really fast at the beginning of the melt season. And the more you melt ice, the more there is water going through your glacier, the more it will slow down after some time. That's why sometimes you have big rain events, big storms on a glacier that dump a whole lot of water, and that is enough to transition from what we call the distributed drainage system to a channelized drainage system. Distributed drainage systems makes the glacier go fast. Channelized drainage system makes the glacier go slow. And sometimes having a storm that dumps water on the glacier is enough to transition from distributed to channelized network, and therefore you can observe sometimes we did that on the glacier I'm studying. We have a beautiful signal from some GPS stations we put on the surface of the glacier. We recorded a very strong storm that dumped a whole lot of water on the glacier, and right after that storm the glacier slowed down dramatically. So that's what happened. We got a channelized drainage system that got created. And that's the kind of difficult thing to think about and to wrap your hand around, is that those systems, the ice being impacted by liquid water, that can happen in a few hours, in a few days. So it can go really, really fast. That will be all for this video, and we'll continue in the next one.